Welcome to ScalaUA conference.
Hi, hello, can you hear me? Okay, so first thing first, I don't know if you can see on the left side, at least on my left side, the screen. If not, on the right side is much better. So, okay, I mean, okay, yeah. So, and if not, here, and I tweeted also that just a while ago, you can get my slides also, if you can see on the screens. So let's start. My name is Krzysztof Romanowski, and as some of you guess, I'm from Poland, and I come from Virtus Lab. And more about myself. I'm Scala tooling developer, and I work on tooling for a really huge Scala projects and Scala code bases. Oh, sorry, I got a typo, nasty typo here. And I'm Zing and Scala ID contributor, and more on that later. I'm also author of Hoarder, SBT plugin, more on that later. And I got 6 years of Scala commercial experience. So, during my work, especially last 3 years on this big of tooling for that big project, I met a lot of compilers. I have to face with the Scala compilation, I have to face with bug on Scala compilation, and in just time I encounter a lot of compilers. And I try to talk with my colleagues in the work about my problems, and I start using, I don't know, presentation compiler, and I saw that they don't know what I mentioned about when I say presentation compiler. So at this time, like the idea to actually talk, to tell you the difference about what given compiler is, and a little bit how it was born. And that's why today I want to tell you, I want to show you some shades of Scala compiler. I don't want to tell how compiler work. I don't want to go into details of type checking and stuff like that. I don't know if I'm clever enough to do that, but at least I will tell you where you can find the Scala compiler, what is the different application of Scala compiler, and what can we do with the Scala compiler except for the compiling our code. So, first question to the public. How many of the Scala compiler is out there? I mean, do you think that there's like more than 2? Just raise your hand. Okay, more than 5? Okay, more than 50? Okay, maybe I should say 20. Okay, so I hope I will answer that question in the end, but the only thing I can say right now, I cannot answer that in precise matter. It is impossible. So, there is some definition of compiler, but I just want to be clear. I don't want to argue with you later on what compiler is and what compiler is not. So let's say I will name what I mean by compiler here. And for me, compiler, especially Scala compiler, in this presentation, is something that takes a Scala source code and understand the Scala source code and understand the types in there, so it can, for example, report a problem and something is wrong with your types, and give you some kind of output. It can be sources or other things, you will see. So if you don't like this definition, if there is somebody that don't like this definition, I can use I can do compiler every time I mention compiler, but I hope, okay, I don't see any hand. Okay. So, first thing first, our good old friend ScalaC. There's nothing to talk about that, except that I will treat. This color does not look that on my computer, so sorry for that, it should be a little bit more reddish. This is a point of reference for me. I mean, for me Scala is not what Scala language specification says. I mean, okay, this is some kind of ideal Scala. For me Scala is the thing that I can compile with our ScalaC compiler. Is there anyone here that used ScalaC from command line, using some kind of make, for example? If so? Okay, nice. Like, I hope that I didn't hope to see any hands right now, and I think I had to change my mind because I thought that John Pretty is the only one that uses compiler from command line. during these days. And there is a crack, as you may see. And those are the bugs in Scala compiler. And there's a few more, but not on GitHub, because they got migrated from the Scala, from the Jira that was used before. Yeah, but it's not much. I mean, we can live with that bugs. So, the second thing is Dotty. Dotty is a new Scala compiler. Who never heard about Dotty? Never. I mean, okay. Never. Okay. I mean, this was right. This question was bad because I already said Dotty, so nobody can raise its hands right now. Okay. So Dotty is the next Scala compiler. This is a thing that Martin Undersky and his team work on right now. And is this a future of Scala? Eventually, it is from the official page of Dotty. So Dotty is a platform where when guys on F, mostly Martin, can work on new feature for Scala. It's Scala compiler written from scratch. A lot of things some things are get rid of Scala. This is this bit on the bottom that is not colored. And there is new things that, for example, try parameters or new things in types, in type level, or even stuff like better pattern matching, and even much more for tooling perspective. I mean, right now, I think if we have to implement, for example, incremental compiler for Dotty, I will more on that later, it will be much easier than for Scala. Because Dotty, with all the experience that was gathered during this over 10 years of Scala, and what is needed actually for a compiler and ecosystem to be a good and for production, Scala compiler was not perfect. And Dotty has to like all this idea, all these requirements for IDEs, for compilers, for build tools in mind, and they try to redesign that. Also, Dotty will be based on dot calculus, so it will be also a platform for academical research. So I hope that a lot of good things will come from Dotty, even if Dotty will never be next to the Scala 3.0 or 4.0 or any 0.0 in the future. Another Scala is type level. Do you know what type level is? If somebody knows what type level is, let's raise its hand. Okay, so type level is an organization, is a group of people brought together by Miles Sabin mostly, and they really focus on get as much as possible from a type level of Scala, and their motto is let the Scala compiler work for you. There are guys behind cats or shapeless. This is probably two most famous things that they developed. And when they try to implement this kind of, I call it crazy type level stuff, they're really useful, of course. At some points, the Scala C is not enough. And at some point, like 2 years ago, this was the quote I mentioned in the beginning about two new forks. One of that was type level, the other one was Paul Phillips one, but the second one is long gone. So type level is the second fork of Scala, let's say. And type level Scala is a Scala with all the cracks because they get what the Scala is, and based on that, and add this. My picture looks really bad. Sorry, I am a programmer, I cannot draw anything. New features like improved compile time from inductive implicits. This is quite new work from Miles. Error reporting or another things. There is of course more on the roadmap, but this is not that they break Scala C to implement that. The idea behind type level Scala is they don't accept that they don't merge any pull requests that have no chance to be merged to Scala C. This is like something like from my view like a Scala compiler beta version, so where there's much easier to get your pull request merged because there is no behind type level Scala there is no like tons of commercial code. If I introduce some bug in the compiler, no Uber car will like crash somewhere, or I don't know, Amazon lost like a few $1 million. It's the thing that you can play with. It's the thing that is released. It's maintained. So and especially if you work on the libraries that will use type a lot, it is really useful to have this better compiler, this more modern compiler. And the most probably famous thing that comes from type-level Scala was the fix done by Miles last year about partial unification of the type constructors. When this was merged to Scala C, I saw like, I don't know, 20 tweets or more that I removed 200 lines of my library, because right now Scala works as it should. And in my opinion, this is the idea behind type-level Scala, is just to allow this kind of fixes. And another great thing behind the type-level Scala that I realized basically during the slides for this presentation is because there is a big cliff if you want to fix something in Scala compiler. If you ask anyone about the Scala compiler, how it's complicated, they will tell you, doesn't bother, it's like too complicated, you will never do anything in Scala compiler. And this is partially true, but it's not that bad. And especially there's a great blog post from Miles about hacking on Scala C, that it is hard, but it's not that hard. And Scala fork, type-level Scala fork, is something, in my opinion, that will actually lower that cliff. So it will be much easier for us, for anyone here, to actually do something for Scala, other than, I don't know, tweak some typos in documentation that anyone can do and anyone should do, of course. But as I mentioned, this cliff is being like much lower when you got, for example, a blog like this, when you can see how to run, how to debug, how to even contribute to Scala, or even contribute to type level. And the youngest one of the compiler, it's triple quad Hydra compiler. Is there anyone here that know what Hydra compiler is? Okay, so I see like 2 hands. I hope that it's like it gets much more audience, but yeah. And Hydra is it's product, it's a new compiler, it's a fork of Scala C, but different, let's say, because it's parallel. The idea behind Hydra is it's a parallel compilation for Scala C, so it should be faster because it is parallel. And I strongly suggest anyone here that is interested in speed up the Scala compilation to Google for the Scala Sphere talk about Hydra compiler by Julian Dragos and Mirko Dotta. So this was quite well-known guys in the Scala community. And the speed up, this is a slide from the presentation. They mentioned over 2 times speed up on like normal developer machine, 4 cores, some kind of Mac. But as far as I know, on the server-like machine with 10 cores, you can get compilation speed up to 6 times. So imagine that you got your code compiled in 10 seconds instead of minutes. It's like, if this will be an option for all of us, I think this will change drastically how the Scala is compiled, what the tool we can have with that. And of course, with the parallelization, this is like no free. So I hope not, but I'm almost sure that there will be much more cracks on Scala with Hydra. Because it's super hard, for example, to even implement the package object in that, to distribute data between the different forks that compile different pieces of Scala. I hope that Julian and Mirko will remove all this, so we get faster Scala, but this is not an open source, this is a commercial product. They probably started beta test right now, but they are closed, so I'm not sure, because I wasn't invited. Yeah, so it introduces a little bit of overhead if you assume the work for all the cores, but not much. So this can be a really exciting thing, like in a few years, in future for Scala. They also promised to implement SIP25. So this is, if I recall correctly, the type traits. So I hope they will contribute back also for open source. Okay, this is actually the end of first part, where I cover like all these Scala compilers that supports like a full Scala. So if you got any questions, like at any point, just raise your hand and ask. Okay, I got one.
I'm more worried about idea speed. Does it help to improve?
What do you mean by idea speed? I mean IDE as a general or IntelliJ speed?
IntelliJ.
But compilation IntelliJ or just the IDE as a platform?
I'm more about idea platform.
I don't think this is actually related to the Scala compiler at all. I'll add this to all the compilers I mentioned, because IDEA platform is independent from Scala, and Scala plugin use something else, and more on that later.
Okay.
Okay. So right now, let's move to the darker side of Scala compilation. I mean the Scala compilers that doesn't support the full Scala. That there are some cracks and holes in the Scala. So why do we want that? Because we got a compiler that compiles everything, so why do we want such compilers? First of all, it's for speed, for different purposes, or for different environments. And the first example of the different environment where Scala C is used, but it's really close to Scala, is Toolbox compiler. Is there anyone that knows what Toolbox compiler is? Okay, so Toolbox compiler, it's a runtime Scala compiler. So you can, inside your program, compile a piece of Scala code and get the values from that code. So this is like, it can be done really easy. You just need to add a compiler to your class path. And in 4 lines, you got any Scala code compiled, and it returns a strange function that takes unit and returns any. And this is the representation of the snippet of the code that you created inside this string. So if inside the string are print line and value, every time I evaluate that function that is returned, a new value that this will be printed on the command line. And you can do crazy stuff here, like declare new classes, objects, load them later on, do some kind of strange things, and all in runtime. So if you got, for example, I don't know, a platform that will allow user to learn Scala or evaluate some small pieces of Scala, this might be useful. Of course, there are cracks, and there are some serious cracks in there. For example, import handling is not that good. There is some problems with positions, and even types are not handled correctly in some cases. And why is that? Because this is a normal Scala compiler with some tweaks, and there is one really big, two tweaks that contributes to most of the problems. First is the class path, how the class path is represented. In normal Scala compiler, you can enumerate a full class path. You can say what is the member of each package. Toolbox Scala compiler use Java class loaders for that. And class loaders, you cannot enumerate anything that you got in your package. You can check if you got a class, you can load that class, but you cannot load the content of the package, because package is not a physical thing in JVM. It's just a suffix, it's just a prefix for a class. And the second thing is that it needs to do strange things with class names, because it cannot generate the class names that are already present. So we have to do some mangling, and this is not quite good with positions and types at some point. But anyway, this is quite useful. I mean, Toolbox is the engine that Scala ID expression evaluator is based on, and it works quite well. And the only problem with the expression evaluator is that there is no option to turn off the private identifier in Scala, and this is really required for the expression evaluator, because you really want to evaluate the private val. But except for that, and the problems I mentioned, it works quite well. So if you got a while, you can play with that. It's quite fun. And yeah. So another environments when Scala is compiled is, as you might guess, ScalaJS and Scala native. And since the problems with the compiling Scala there does not come from that the compiler is different, but it comes that there's not always let's say representative of, for example, JVM parts. So what can be used in Scala is different. And to be honest, there is much more thing I want to mention in this presentation, so I will skip that one. I will just leave you with the links to the pages and some few presentation if you are interested. Especially Scala Native is quite interesting. I mean, as far as I know, they want to use Scala Native, I mean to compile Scala compiler to native and see how much better will be this compiler compiles to the binaries. We will see. It might be really interesting. So, any questions at this point? Okay, I see one.
Is this toolbox compiler implemented under, well, have anybody tried to compile? Have anybody tried to compile this toolbox compiler under JS so that you can use it from JS without any server side?
To be honest, I have to check that, but I will say that there is 80% chance that it will work out of the box.
That's
But
cool.
yeah, but I have to check that. Probably you just need to take this piece of toolbox code and run it in the JS side with the Scala compiler on the class path.
Yeah, thank you.
There's one.
Yeah, I think concerning Android and Scala, I think right now it's kind of a big issue because they don't support Java 8, but will maybe again. There you need a very restricted Scala because otherwise you blow up the device with running Scala program, and especially with the libraries.
Yeah, I recall I tried to do a compilation for Scala. It was like enormous time was taken actually to analyze all the libraries and see what is user and what is not. So yeah, I don't know if unless they got the proper JVM, I don't think the Scala on Android is a good thing right now. Maybe Scala.js. Okay, so let's move to next thing, incremental compilers. So the first thing first, and we need to know what incremental compiler is. So there is a, if you look at that, like just based on the name, you probably guess right. Incremental compiler is the idea of incremental computation applied to the compilation. So, with that in mind, do you think that we got different compilers to be incremental one for Scala? So, if you think that there is a different, like completely different build from scratch compiler for incremental compiler for Scala, if you can you raise your hand right now? Do you think so? So okay, there is a one. We will see. So this is interpretation. Maybe skip that. And incremental compiler for me, and I will describe this later, is just a driver for Scala. For the normal Scala compiler, it's nothing more. Because we don't get any special incremental compiler in Scala. We got two, as far as I know, and both are drivers. So they basically drive what is compiled. So, I don't know if you see the colors well, but in this situation, we got two kind of sources. This one is changed, this one is not. And we got the classes from the previous compilation. And we feed that to incremental compiler, and it will behave exactly the same way as a normal compiler, that will compile anything, delete the classes, and give you new updated set of class files. But to save some time, we know that this first sources does not need to be recompiled. So incremental compiler is here to decide that this source doesn't need to be recompiled, and it needs to compute what is required to be recompiled because it's changed or dependency changed. So it takes the subclasses, feed that to the normal Scala compiler, and it will get the new classes back and merge with the old one. Of course, none of the Scala compiler, I mean Scala incremental compiler, sorry, is that good to know that from the start, that's looking at the change. So there is a cycles. So if you change one file and use a trait, that allows trait extends from or mix in that trait, you don't know that at this change because you don't know the type change or the member change. You see that only the file is changed. So we compile this trait, you see that, let's say, member change, method change, so you need to recompile every other usage of that trait. And it can go a few times. In, for example, SBT, it can go at most 3 times because the third compilation will be the full one. And in the end, we got the classes. So, if some questions about the idea? Okay, I hope it's quite simple. So, the first incremental compiler is called Zinc. Do you know what Zinc is? I mean, do you know where you can find that? And how can you use, or did you ever use Zinc? Okay, there's 2 guys. 5, 7. Okay. So for the rest of you, this is nothing else than SBT incremental compiler. The name was a little bit changed, and in the end we got Zinc. Because in my opinion, like when they try to do that, because SBT incremental compiler was way too long, they end up with Zinc. That does not sound good, so that is why we got Zinc. But this is a theory, and I asked the Zinc developers, and nobody recalls what the Zinc comes from. You all, to be honest, are using Zinc right now. Maybe not called as Zinc, but this is a part of SBT, and this is a part of each SBT. So, there, of course, for the SBT 013 and older one, it was mirrored and like it was actually copied some classes to typesef hub and used, for example, in Gradle. I don't know about Hans and Basil if they also use Zinc that version. But right now, it's pulled to SBT away from SBT. Like in SBT 1.0, there will be not Zinc will be not a part of SBT, and it will be like used between different build tools. The only build tool I know that uses Zinc 1.0 on the production right now is ScalaID, because SBT 1.0, I don't know if anyone is using SBT 1.0 because it's not ready for being released as a stable version. So we need to look at this again beautiful picture of mine about how the Zinc and compilation, and especially compilation bridge idea work. So, do you know that even that you are on 2.12, I hope all of you are on 2.12, SBT and Zinc is still on 2.10, and it will remain that until SBT 1.0. So, we need to do something to allow our SBT tool and our program, our Zinc compiler, that is on 2.10, to compile to 12 Scala workspaces, and even more, not only compile because it can be done from command line, but interact with those workspaces because we need this information, I mean, this communication between Zinc and this ScalaC inside. So how this is done? The idea behind this is called compiler bridge. So basically this ellipse here represents this compiler bridge, and this is not normal Scala code. This is a Scala sources and some Java code. And the idea behind this is that those Java sources are compiled for the version of Scala that your project uses. So maybe you recall, but this is done like once, when you change the Scala version, SBT said a compiler interface not yet compiled for your Scala version compiling. This is doing this compiler bridge. And to communicate, because Zinc not only run the ScalaC, but also insert some things to ScalaC and change ScalaC itself, because it slightly modified the global object that is a core for a compiler, and insert 3 new phases to get the data to compute the relations between the class source files. And you need to communicate back, and this is done by Java API, and those Java API should be called the grandfather of Scala meta, because with those Java API you can represent any type in the code, any source, and this is work with all the Scala versions. And Zinc right now is tested like if it works with the same code base with 2.10, 2.11 and 2.12. So I always think about that the Zinc was a Scala meta before it was cool. So Zinc in theory should be a normal Scala. I mean, because if you do a clean compilation, there is almost nothing going on there except few phases that actually are read only the bytecode, read only the metadata from the compilation. But this is quite optimistic, because for example in Zinc 1.0 there was a bug that shapeless, because of Zinc, compiles for half an hour for one module because there was a loop. But of course this is a bug, so it's fixed, so don't worry. But there is the dark side also of incremental compilation, and it's actual incremental compilation. if you can imagine how many programs that you can create for Scala, how many features can interact with each other, it's like enormous number. I don't know if Scala right now have unit tests for at least 10% of possible Scala programs. And incremental compiler has much more things to check and test and support, because it does not need to support only every possible Scala program, but it needs to support every possible transition from any Scala program to another Scala program. So the amount of possible, the ways how things can broke, the ways can, can change, import, and it should recompile all of the sources of your program. It makes that for the clean compilation, Zinc is a normal Scala, but for incremental compilation, you might be affected by some nasty bugs. For example, like the really one that this was like discovered recently, that Zinc does not work well with inlining of the values. So we got, I don't know, HTTP port, that is this final val, and you change that, and you might not see this HTTP port change in other sources of your program. Because this is a fault of Scala actually, because it is try to improve the performance of your programs and inline that value exactly in your code. So when the Zinc kicks in and try to analyze that, it does not see that it comes from some kind of value. It is just an int for the Zinc, so it's like ignored. And this is a big problem, and I don't know if Zinc will be, with the current version of Scala C, will be ever able to support that. And there's a small shameless bug. I mean, based on Zinc, I create a library to speed up the compilations between machines, to actually do the incremental compilations between different machines, for example, to use the code from the CI on your local build. It's called Hoarder. If you are interested, go there. And it's quite new thing, it's not well tested, but I'm still working on, so I hope it will help you later on. End of that. Any questions for Zinc? Okay. So the second incremental compiler that we got is INTELLIJ incremental compiler. And if we look at that, it's quite similar to Zinc, but there is few things there. First of all, the Zinc is used in the middle. But it's not the incremental compiler, but the compiler bridge idea. So INTELLIJ can be implemented in any Scala version that they want, and it can compile any other version of Scala, including, for example, .if. And the second interesting part of this is that INTELLIJ, as incremental compiler, is not Scala specific. INTELLIJ incremental compiler is JVM specific. So the same incremental compiler is used for Scala, the same incremental compiler is used for Java. I don't know about Groovy, but I'm sure about for Java. And it has nothing to do with Scala sources. It just analyzes the relation between the bytecode classes. So it means if you got change implicits, it will be not handled correctly with INTELLIJ. If you got a macros, forget about some kind of incremental compilation that will work really good for you. And it's the same story as with Zinc. If you got incremental compiler, the clean compilation is you got the full Scala. If you got the incremental ones, due to the bugs in the incremental compilation, so you don't recompile every required sources, the bugs can creep in. So beware for that. And there is another kind of compilers that we have. It's called presentation compilers. So, have you ever used presentation compiler in your life? If so, just raise your hand. I see 4 guys. Okay, so have you ever used, I don't know, INTELLIJ, Scala IDE on Enzyme or any other IDE? If so, just raise your hand. You guys using Notepad? Okay, so presentation compiler is integrated part. It's a part of every IDE. Without presentation compiler, your IDE will be just a text editor, more or less. Because the presentation compiler is the thing that gives you errors when you type, gives you information for code completion, or even gives you the data to do some refactorings. So without presentation compiler, any IDE is pretty much a text editor. And presentation compiler have quite different requirements than the normal compiler. For example, the compiler should just produce a bytecode, should just compile the code. But with the presentation compiler, it's more like to answer the questions. So I need to know if this code is correct. I need to know what is the parent of that class to actually, I don't know, to change the parents. I need to know what import is used to sort the imports. This kind of stuff. So presentation compiler is more about answering the questions of IDE than actually compile the code. Another thing is when it should fail. I mean, compiler should fail when there's a first error, first problem. The compilation should fail. You need to fix that error and go like further, compiling the next batch. But for presentation compiler, it's not that simple. It should, if there is a failure in your code in one part, it should at least try to give as much data as possible for the other parts. So if you do some small mistake inside the private function that does not affect the return type, the rest of the file should work because you got the types. So also the presentation compiler, as you can imagine, it should be interactive, so it should always work and always reply the questions. But normal compiler is a batch mode, so we just ask him to compile a batch of sources and get the results later on. And the last, probably the hardest one to do, is that presentation compiler does not only answer the Boolean question, is the type correct here, because it will be quite easy, but you need to provide a lot of data for other tools, like as mentioned before, the code completion or error factorings. So with that in mind, let's go to the presentation compiler from INTELLIJ and how it works. And this is the first time there is no ScalaC in the picture, because INTELLIJ presentation compiler has nothing to do with ScalaC, except that they work on Scala. And it's implemented that it's like, if you want to know what type of given field, you just ask you parse the code, and there is, I don't know, some other class mentioned there, and you don't know the type. So you ask the cache. If it's not cached, you ask the source when this file can live, and you actually start to do a compilation, like let's say compilation of this under source, actually to get the type that is required. But in some point you actually miss another type for list, and you ask the cache. There is a hit in the cache. You got the list, you got the type. And there might be like tons of the types in that file, but you don't need to parse that types. You just need this type of bus, and you come back to the original source. So with this, it can be really fast if you got not crazy code bases of Scala, and it can work even if you got a bug somewhere. So if you got like one private method does not produce correct type, so there is a bug, it doesn't matter, because if you ask for the type of the outer class, it is there. And it's also the pictures like that, so where you see where that the INTELLIJ is analyzing the code, is not that often. I mean, I have to be really quick with the print screen to get this one around your problem, just the required pieces. And let's look on the stable. I mean, what is supported and what is not. So it answers the questions, and it provides as much data as possible, because if there is something missing, there's just missing, and there is an error type inside the structure. It's interactive. Initial batch mode is really small because you have to populate the cache. So for example, you have to index the whole Scala, but it is done before you start typing, when the INTELLIJ is analyzing the libraries. Oh, sorry, and there is to do. I should remove. Sorry, guys. And I don't know if you see that the dog on the top is black and the rest is brown, and this is like the INTELLIJ incremental compiler is the only compiler that does not come from Martin Odersky, or does not use the code that Martin Odersky wrote. However, there is a connection, because Jason Zhao, probably the second guy in the Scala compiler right now, contribute a lot, like few years back, to INTELLIJ incremental, to INTELLIJ presentation compiler. And there is a lot of holes in that, because it is not the Scala compiler. It is like from this interactive mode, and this requirements to be really fast. I mean, at least fast, and it gives you a lot of data and work of sources that does not class load the stuff on the run, and like especially to be fast, it does not support, like for example, big implicits and strange higher kind of types. That's at some point Miles, that was like really not happy with the users that does not use shapeless to its limit, says, because IntelliJ doesn't support that, said tweet this like 2 weeks ago probably. So yeah, so we got like a two parallel world. I mean the things that IntelliJ supports and the rest of the Scala. And back to that, there is of course one big problem here, and this is that a lot of Scala code right now is using macros, either white box or black box, and IntelliJ does not know about macros because this is written from ScalaC itself. But they hope that when the Scala meta will be popular and everybody will switch to Scala meta, this will be no longer a problem because you write your programs against Scala meta, not against Scala compiler code, and it can be used in the IntelliJ without any re-implementing of your macros. How much time I got more? Okay, so let's go for a Scala C presentation compiler, because as you might guess, our Scala C also got the presentation compiler mode. And another diagram. So it's worked quite as an incremental compiler, but not to its limit. I mean, you start with both classes and class files and source files. You don't need this one, but you can skip that, but it will be like much slower because it has to recompile everything. And then it's using the incremental compiler part, let's say, and try to find all the classes that need to be recompiled, and the classes are recompiled in Scala C. And normally it will end up with the class files. But with presentation compilers, the last phases of Scala C are turned off, so there is no class files. The only response that we got from the Scala C, it's type classes, all the AST information, all this compiler internals. So this has got this big problem that it is a Scala compilation, so it is slow and it is a batch mode. So yeah, so as you must expect, you can answer the questions because you can parse the output. The problem is that if your code does not compile, if you ever use a Scala ID, you call that. So if you just do one mistake in the types, all your sources, like all the code completion is gone unless you fix the problem. So it's all or none. And it's not exactly interactive because it's still a batch, but the batches are usually small after a big initial batch. So it's quite interactive, but not so. And data that are provided are actually, you can do this as errors or warnings from the compilation, but they are not that much useful. But if you want to some more sophisticated one, like get the members from the class, you have to do as a callback to the Scala compiler internals, and the problem is that you need to write your code for the given version of Scala C. And that is why Scala C is released based on the Scala version. And the problem here is you either got the full Scala, but a completely full Scala with macros with crazy stuff, or none, if your program doesn't compile. So Miles does not, and his tweet doesn't apply here. For Scala ID and Scala presentation compiler, you got everything that Scala compiler supports, but sometimes you get none because you got compilation error or timeout is reached. Do you want more compilers? So there is a thing called Kentucky Mule, and this is an idea by Grzegorz Kosakowski, the guy that is behind that improved Zinc compiler and introduced a name hashing algorithm, but to explain that is another talk. But this is like 2 weeks of work. It's actually the research to see how fast we can do with the Scala compilation and what is the limits of the time that need to be spent compiling Scala code. Macro Paradise. If you use Macro Paradise, you actually create your own compiler because the thing that is compiled with your macros is no longer a Scala because it doesn't support by Scala. And it goes with the compiler plugins. I know the code bases that without the compiler plugin will not compile at all, but even if they compile at some point using some crazy stuff, the bytecode will be completely different. Because, for example, I don't know if you heard about async plugin for Scala, and this actually turns your normal Scala code when you add some annotations or like marker code into completely asynchronous code base where some results can be cached, this kind of stuff. So the output of the bytecode is like 10 times, sometimes bigger than you expect from normal Scala. So if you just apply one simple plugin, you can get a completely different Scala. And it goes even further to the macros, or even DSLs. So if I want to answer the question, how many Scala compilers are there? You cannot count them, but you can say that there are 3 main branches: ScalaC, Doti, and IntelliJ presentation compiler. So, and there is like a bunch of various variants of that. We've inserted phase for incremental one, we've cut some pieces to be a presentation, or with some pieces added like Hydra to be parallel compilers. But there's like three main branches. So this is like all I think I got time for. So if you got any questions, this is the best time, or you can find me somewhere in the audience, on the venue here, or chat on the Gitter or anywhere. Thank you. Okay, I see a question there. I think we got the time for a few more.
Given the Scala is very complex and there are so many different compilers, isn't it maybe a waste of scarce human resources behind the Scala language to have so many?
I mean, is there too much, or is not enough, or is...
Too much because it's very difficult to keep them in sync, and Scala is difficult by itself.
I mean, yeah, but we need to serve different purposes, and we got like tons of developers right now, and I think they deserve for tool as good as possible. And we are still not catch up Java. We still got some problems with tools around Scala, so I think we should put even more effort into the actual compilers and work around compilers and stuff like macros. Complicated thing a lot, but with ScalaMeta, that I think is the future. For every tooling developer, we can actually do not repeat the same work twice. For example, if you want to support that your macro will be supported in IntelliJ, you can write the plugin to IntelliJ to support your macro, and you need to write your macro. But if you build your macro based on ScalaMeta and this will be supported, you will get this for free. So I think there's not all this work that was not wasted. It was invested for all of you, and I think there's a little bit there's almost no appreciation for the guys that work for toolings, because tooling for a Scala is not that let's say sexy as new functional library. I mean, if you add ScalaC or cuts to your presentation, everybody gets interested. If you want to do something about SBT. No, maybe not this time, because we don't like SBT, because it just have to work. So what I think we need to a little bit change our minds to actually give more thanks to guys that spend a lot of times and lives creating the tools. And to be honest, tools are way harder to implement than normal programs. Especially if you start to work on tools, you will completely change your mind about how hard tools can be to implement.
Okay, thank you.
There is a question.
Yeah, I think it is an important thing to keep these different branches kind of in one row. I have seen a language which is not worth mentioning, but they had 20 flags, how way you configured the language behavior, and then you could only use libraries yet happen to use the same combination of these 20 flags.
We got, 80 flags for ScalaC, but God, they are work with all whenever you turn on it works just so.
I'm not sure, but I think I heard about special fork for compilator that claims to preserve stability. Do you know about that?
Any details? Like who, where, when?
No, I cannot remember, but it's from Java perspective, Scala is developed very fast and sometimes breaks backward compatibility. That's all. Maybe you know, maybe not.
I think that, this is like a good point. I mean, Scala, if you change Scala to 10 to 11, you need to release all your libraries in different version. And this is a good point. And as far as I know, they plan to freeze bytecode around at the end of 2.12. Or at least that does not change that much, but we will see.
Okay.
Okay. Okay. Thank you. Thank you for all these questions, and let's get some lunch.
So, right now in Ukraine, there's the best possible time to be a Scala developer because everything is forming up, everything is fresh, and also you got good examples how to do a community, how to run a companies from, I don't know, Poland or like States or any other country. So right now you can take a look what we done wrong, what is the problems, and start anew. And also in this moment you don't have any burdens, any contracts that you have to fulfill. You can start your own ideas based on the failures that we did in like other countries and develop. So learn a lot from our failures, mostly our failures, and create a great community for Scala developers to be, because it's really surprising because in the past few months I even got the job offers here in Ukraine, so it's really amazing. I mean, good work, guys.